So today we're doing a lab over molecular bonding. So this lab has 5 activities that we probably could only go through 1 or 2. The first lab has a table over the different periods in the groups, and we're supposed to make the Lewis dot structure of each of them. And there's about 14 that we have to fill in for each element. And so that's for activity 1. And then activity 2 is, as you can see right here, I have them split up. So all of these, this one is for 5 electron pairs. The reds are for oxygen, 6 electron pairs. Nitrogen is blue, hydrogen is white, other atoms, the black is carbon, and then the ones that have 3 prongs are for the electron that has 3 pairs or bonds. And so for activity 2, it says that we need to make a molecular shape or molecular bond shape to it with these. So from the activity 1, so activity 1 is an example of silicone and oxygen, 2 oxygen. So the middle part, this one right here is the silicone because it has 4 electrons, valence electrons, and then oxygen, they each have 6 valence electrons connected to them. So I picked the silver because the silver is 6 electron pairs. So I picked this one, so it has 1, 2, 3, 4, 5, 6, and this one right here, 1, 2, 3, 4, 5, 6. So this right here, and these are covalent bonds right here. So this is an example of the silicon with 2 oxygens on the end. That is technically the only example that they have for the Lewis structure dots, but I guess, let's see, I can do a different one. No, probably not. Right, and then also I'm going to go over the third. Well, actually, this is the second activity. So what you had to do is you had to blow up balloons, and I blew them up. So here's the first one. That's 2, 3, 4, 5, and 6. And then with these, we have to make 3D dimensional models of each molecule from activity 1 using the molecular model pieces as shown below. And so this right here was an example of that. And that's everything. Actually, we've got another activity having to do with polar and nonpolar bonding. And then the 5th activity is over modeling hydrocarbons. And that's a review over this lab. Thanks for listening.